All right, so here is we're describing a graph of a hyperbola function, uh, hyperbola. And so what we want to do is first the shape. You might want to say two curves. You might even want to write maybe in parentheses that they're opposite of each other, something like that. There's no right or wrong answer. A line of symmetry. Now, we didn't talk a lot about this, but the line of symmetry goes in between these two. So it's going to be here, 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 here. It's going to do something like this. So imagine if I had a piece of patty paper. Actually, I should do that in a dotted line. It's going to go like this. Now, I don't need the equation. If you just said yes, that would be all I would need on this. But if you wanted to write the equation, it's going to be y equals negative x minus 4. Or you could just write yes. It opens up and down. You might even say here right left your vertical asymptote. So this right here is the vertical asymptote, and so that's at x equals negative 2. My horizontal asymptote is at y equals negative 2. Increasing. Now these are tricky, so we always go to our little guy and we always start on the left hand side. So as he walks or she walks down or across the graph, what is it doing? It's decreasing. Okay, then let's say he makes the jump over here, and what's happening here? Our gal is just walking and it continues to decrease. So this function is decreasing. So we would say yes, no, or none, because it's definitely not increasing, it's decreasing as we go from left to right. Now the x-intercepts, so we cross the x-axis right here at 0, 0. And then our y-intercept is also 0, 0. That's convenient. The domain is going to be, now realize we go infinitely this direction, infinitely in this direction, and the only value it can't be is negative 2. So we could say all real numbers except x equals negative 2. Or you could put something like that. And the range is the same thing. It's going to be all real numbers except y equals negative 2. Are there any endpoints? No. Is there a maximum? No, or none. Minimum? None. Is it continuous? No. Or actually we should say it's discrete. And what's making it discrete is our asymptotes. And then is it a function? So remember, it has to be 1 to 1, and in this case it is. So yes, it's a function.